Hello guys, welcome back to another episode of COVID Chemistry. Today we're looking at chapter 4 of the IGCSE chemistry course titled Useful Metals. A lot of information within this chapter. We are going to try and somehow, crazy I know, somehow review it all on one whiteboard. You can see behind we have a lot of information for our template. So before we begin, I'm going to jump out of the video. As always, you're going to pause the video, and on your piece of paper, you are going to make the template we have, and then we are going to work through the content together. Okay. Okay, now I hope we're good to go. So we have a few definitions we need to get through, a bit of homework that you are going to also be doing, or two pieces of homework actually. So you will need to refer back to your IGCSE chemistry book that I emailed you recently. Okay, so our definitions that we want to start with, we are going to look through what we mean by an alloy, what we mean by stainless steel, what we mean by a high carbon steel, low carbon steel, and a metal carbonate. So the first thing we want to be able to answer is, what is an alloy? And in order to do this, I think we should take a step back and first reflect on the structure of our metals just as a pure metal. Okay, so a metal being a solid, we normally just see our regular arrangement of our metals like this with our metallic bonding. And just a bit of revision, you will know within here that we have our delocalized electrons within our sea of delocalized electrons that can carry charge. So pure metals like this, we can see from our arrangement that what is going to happen. They can easily slide over each other like this. However, an alloy, it is a mixture of different metals. So an alloy, we can identify the structure like this. So with it being a mixture of different metals, oh, terrible drawing here, but we can kind of identify that we are going to have a stronger material than our pure metal. Why is that the case? Because if we compare and contrast the two, can easily slide over each other. However, an alloy being a mixture of metals, we can't really have this sliding motion between the particles. Looking at that, it's a bad drawing, but I hope you understand what I'm getting at here. So, we're going to define this. So what we mean by an alloy is basically a mixture of metals. There we go. And what we can say, an alloy is stronger than just a pure metal substance, referring back to that drawing I attempted there. So we have these alloys, mixture of metals, we cannot really have this sliding motion between these particles. Okay, so what is an alloy? Mixture of metals. The next question we want to identify is, what is steel? You would have heard this word before, very popular word within industry, and I would imagine if you walked into your kitchen right now, you could probably identify something made of steel. Well, steel, it is simply an iron, carbon mixture, alloy. There we go. So an alloy is a mixture of metals, and steel is an iron carbon alloy. Nice and simple. Okay, so step 1, step 2. Let's go on to our second subsection, point number 3. We've identified steel. Is now talk about this stainless steel. So stainless steel, what exactly is it? So it's an alloy. It is an iron chromium. An iron chromium alloy. Also contains other things. Also, it's also made up of carbon, silicon, and manganese. Very important that we can identify these things that are making up our stainless steel. So an iron chromium alloy that is also made up of carbon, silicon and manganese. Why do we use it then? What is it useful for? What are the properties of this stainless steel? Very important word. It is resistant to corrosion. It doesn't rust. It is very strong. It doesn't wear down very easily. So it's resistant to corrosion. It is strong. So our stainless steel, our iron chromium alloy, made of carbon, silicon and manganese, is resistant to corrosion and it is very strong. Okay, this is nice and simple then. We've done number one. Number two, let's look at a little bit more detail. We have two types of carbon steel. We have high carbon steel and low carbon steel. To differentiate between them, they have a different carbon content, and from this they serve different purposes, or they have different uses within our everyday life. Carbon content of high carbon steel. I'm sorry, I'm right-handed. I always need to go to this side to write. So if I'm blocking behind me, I do apologise. So the carbon content of high carbon steel is anything above 0.55%. There we go. Its uses, it is very, very strong. It's durable. It is used in the railway industry. It's used for railway tracks. High carbon steel, strong. We can associate these words together. It has a high carbon content. It's very, very strong, okay? So use in railway tracks. Why is this the case? It's strong, it's hard, it's doing its job to hold these trains along these railway tracks. Low carbon steel, let's follow the same template. Carbon content and uses. So, low carbon steel is anything below 0.25% carbon, okay? What does that mean? Well, it's not going to be as hard as a high carbon steel. It can bend more easily, it's more lightweight. So, low carbon steel found in cans that are storing your vegetables. We're all about to go into quarantine, it seems like. We're on lockdown. Open your kitchen doors, you'll have lots of these cans storing food in there for you. Okay. Using cans, also used in car parts. I'm not going to write car bonnets, I'm just going to write car parts. So it can be bent, it can be moulded into different shapes. It's lightweight but still strong. So your car bonnet, the front of your car, which is protecting the engine area, is made up of low carbon steel. Wow, lots of work so far. Alloys, stainless steel, high carbon steel, low carbon steel. First checkpoint, first piece of review homework I have for you is what we call metal carbonates. Okay, let's break this word up. We are seeing this pattern here. Carbonates contain carbon and oxygen, so metal carbonates. Review pages 60 and 61 of your IGCSE chemistry book. And then what I would like to do is answer the summary questions on pages 61. Whew, lots of work. Shall we continue though? Let's have a quick review. We've answered what an alloy is, a mixture of metals, happy there. What is steel? It's an iron carbon alloy. These alloys are stronger than pure metal. Why? Because pure metals have these regular arrangements of just one metal. They can slip and slide over each other if force or energy is applied. Alloys, a mixture of metals, these different sized particles. What does that mean? We can't really bend these structures. Stainless steel, iron, chromium alloy also contains carbon, silicon and manganese. Properties, resistant to corrosion and it's strong. High carbon steel used in railway tracks, low carbon steel using cans and car parts, high carbon steel content above 0.55%, low carbon steel below carbon content 0.25%. Oh, usual metals, right, let's keep going. We want to be able to talk about reactions that take place in order of our reactivity series of metals. This is a very common thing within the GCSE course, to be able to remember, reflect on and incorporate this knowledge of the reactivity series of metals across a wide variety of content. There is a very common rhyme that we use in the classroom. You can make up your own rhyme or you can just follow this one. We want to be able to talk about reactions with water, of our metals that I'm going to list, and our reactions with dilute acid. Okay, so order of reactivity, we have potassium, sodium, lithium, and calcium. Okay, so all of these four here, when reacting with water and dilute acid, they follow a similar pattern. They are going to produce a metal hydroxide solution. So when reacting with water, we are producing potassium hydroxide. This is an alkaline solution, and we can prove this by putting universal indicator into this solution. We're going to have a colour change of a very dark blue, more purple colour, the end of the pH scale colouring towards our alkaline colours. Hydrogen gas is also given off. We can visually see this given off. And we're going to have a fizz. We can actually see this reaction taking place. Reaction with dilute acid, I've been a bit dramatic here. Explosion or having a boom, we can hear this happening. So, first section, we need to be able to talk about this. Potassium, sodium, lithium, calcium. Please send lions, cats. Now let's go into our next step. Our next one, we are going to be identifying magnesium, aluminium. For our Americans out there, aluminum. So please send lions, cats, monkeys, and zebras. Ooh. In. Okay, I'm going to stop there. So, our four here, when reacting with water and acid, very similar once again, less reactive than our first four. They are reacting with steam hydrogen gas given off once again, but the difference from when our hydroxide solution is formed, we are producing a metal oxide, magnesium oxide, aluminium oxide, and so on. When reacting with dilute acid, a phase once again, we can see this happening. Hydrogen gas formed, hydrogen gas given off, and what we say, a salt is formed. What do we mean by this? A salt is formed. So, for example, magnesium reacting with sulfuric acid is going to produce magnesium sulfate. Aluminium reacting with nitric acid, aluminium nitrate, and hydrogen gas given off. So this pattern like this. Okay. Please send lions, cats, monkeys, and zebras in tube tin. Lovely, okay. Tin lead, slight reaction with steam, we're not really going to see much. We can see how, as the order of reactivity goes down from most reactive to least reactive, we're not seeing a reaction taking place. Slow reaction, slight reaction. Okay, recap. So, please send lions, cats, monkeys, and zebras into lovely. Okay, I'm going to place hydrogen within here. You might be thinking, well, hydrogen isn't a metal. Should have been a reactivity series of metal, that is correct. But hydrogen can be used to extract metals within a reaction. That is going to link to a piece of homework you are going to be doing for me at the end of this. So, into lovely hot. Let's keep going. Countries. Signed. General. I'm going to put this final one at the end, but we don't really need to identify platinum. Okay, so copper, silver, gold, platinum. That is a reactivity series of metals we want to be able to identify, and a further breakdown with our reactions that are taking place with water and our reactions with our dilute acid. Your second piece of homework from this content, I would like you to review pages 58 and 59 for what we say our displacement reactions. A more reactive metal taking the place of a less reactive metal. And then finally, answer the questions on page 59. So this is a lot of content to do. Please take your time. I'm going to jump out of the video. You can pause it and reflect on anything that I might have been blocking. I do apologise. So, 2 pieces of work for you to complete. Task number 1, review pages 60, 61, answer questions on page 61. Review pages 58, 59, and answer the questions on page 59. Thank you for tuning in once again. This has been chapter 4 of the IGCSE chemistry course, Useful Metals. Thank you.